Hello. So this is part two of Unit 3, Lesson 1. Now, you've never seen this before. I actually want you to investigate this on your own, but I am away on Thursday. So here are some definitions that you need to know, and the reason why we're doing this is because now we're going to deal with an angle that is greater than 90 degrees, possibly greater than 180 to 70, 360, and on and on and on. So if you take a look at this, a unicircle is a circle with a radius of 1. So it has a unit as the radius. That's why it's a unicircle. Now the initial arm, so I just drew the unicircle down here. Okay, so I can say this point is at 0, 1. This point is at 1, 0. This point right here is at -1, 0. This point right here is at 0, -1, since the radius here is 1, right? And then it says initial arm. Initial arm is this. Okay, initial arm is this. So hopefully you can kind of see, oh wait, initial arm, isn't that the x-axis? Well, it's not the x-axis, but it's the arm that rests on the x-axis. So we can say that this is a starting arm, because that's where your arm starts to rotate. Okay, so starting arm, we can say that. Now terminal arm means that the arm actually ends. So this is the terminal arm. So this is the terminal arm, because from the initial arm we rotate it and then we stop there. So the terminal arm is basically ending. I'll say arm, the simplest way. Again, I'm not going to ask you to memorize the definitions, but I want you to know what the definition of each is so that you can use it. At the same time, when I use these terms, you don't get confused. Now, the reference angle is then the angle, but before actually we get into the reference angle, let me just explain what the principal angle is. So the principal angle is how much you rotate from the initial arm to the terminal arm. So this is basically rotation, rotational angle. Then you're going to ask me, what about the reference angle? So the reference angle is the angle between the x-axis and the terminal arm. So for example, I'm going to use red in this case. If you have a terminal arm right here, this is your principal angle. However, this is your reference angle, okay? Because this is the angle between your terminal arm and the x-axis, okay? So those are two different angles, okay? Those are two different angles. Now, having said that, let's then get to the next page. So we're going to go through an investigation, but I'm just going to explain through this, okay? So here we have a unicircle with a terminal arm. I'm rotated from the initial arm. Now, here from the given diagram below, draw the same triangle with the baseline on the x-axis. So if you can see it, the triangle actually, the terminal arm landed here with the first point per se, which is like this point, and this point, somewhat the same location-wise in terms of the rotational angle or the reference angle. So what I'm going to do is I'm going to draw the triangles. So I have then these ones. Okay. Now hopefully you can see that this angle over here is the same as this angle, and this angle. So all the reference angles are the same. Now if the reference angle is 30 degrees, so if this is 30 degrees, what about what is the rotational angle that give the same acute angle in the three other triangles? So what it means is that what is the principal angle of each triangle we have drawn there, which have the same reference angle. So what is the principal angle? Basically it is from here to there. That's the first reference angle for this triangle. So remember, this is 30 degrees. So the first one will be, the blue one will be 180 degrees. minus 30 degrees, which is 150. Now then the next one is then from here to all the way down here. That's also 30 degrees, right? This is also 30 degrees. So this means that it is 180. So we rotated 180 degrees and then we have to go a little further, which is 30 degrees. Then my third principal angle is 210. And then lastly, I'm going to use black. Then is all the way here. We know that this is also 30 degrees. We know that it is just 30 degrees before a full rotation. Now, hopefully remember the full rotation is 360 degrees, but it's a little less, which is just less of the 30 degrees. That means we have 330 degrees. So hopefully you can see this, that 30 degrees, 150 degrees, 210 degrees, 330 degrees give the same reference angles, right? They are all different principal angles, but they're all same reference angles. And there's a very important point to this. Okay, and we're going to actually go through that. So then the next question says, if the reference angle is 30 degrees, what is the length of the baseline? So I'm going to erase all this for now. Now let's actually find the triangle's baseline here, because it says if the reference angle is 30 degrees, what is this baseline? Now remember that this is a unit circle, so we know this hypotenuse, which is the radius of the circle, is 1. So it is going to be easier for us to then find the baseline. I'm going to call it x since it's the side way, and the height, which is the y. So let's actually try that. Okay, so let's actually try this. So in order for us to find the baseline, which is the x, we have to use cosine, since this is the hypotenuse and this is the adjacent, right? So according to SOHCAHTOA, that is the cosine. So cosine 30 degrees is then x over 1. Now, instead of using a calculator, remember 30 degrees is one of the special angles. And hopefully you memorized this already, that cosine 30 degrees is the square root of 3 over 2, which gives me then x over 1. So this basically tells me that square root of 3 over 2 is my x. So my x is then square root of 3 over 2. Then what about my y, which is the height? So same thing. So it will be sine 30 degrees. Why is it sine? This is the opposite side. This is the hypotenuse side. So we have SOHCAHTOA, we have so. So then sine 30 degrees is the same as y over 1. And then we know that sine 30 degrees is 1 over 2 from the special angle triangle, which is y. Therefore done. We have y as 1 over 2. Now, funny thing is, for the other triangles that we drew before and then I erased them, they all have the same 30 degrees, 30 degrees, 30 degrees as the reference angle. So then what do you think their base length and the height length? Well, they should be the same since they are pretty much the same triangles, right? So they're the same. So they are all, in terms of the lengthwise, all 1 over 2 as the height, and then square root of 3 over 2 as the base. Now then, the question is this. We are working on a Cartesian plane system here right now, and we know that the length of each base is square root of 3 over 2, right? So if you look at it, I'm going to erase this part. If you look at it, we know this length is a square root of 3 over 2. So that means I am going to the left side by square root of 3 over 2. So that means this part is a negative square root of 3 over 2. And we know that the height of the triangle is 1/2, but it's going to the positive way, which is up. So we know that this point then will be negative square root of 3 over 2, comma 1/2. And same thing applies to the next triangle, which is right here. that this now has this, well, sorry, the height of 1/2, but it's now going downwards. So then it will be negative square root of 3 over 2, comma, negative 1 over 2. And this point is the same way. However, this time the base actually is going into the positive direction. So it will be square root of 3 over 2, positive. Whereas the 1/2, which is the height, length of the height, is in the negative section. So it will be negative 1/2. And this one, we have positive and then positive. So these are the coordinates of each point. Okay, so that's what it's asking. So what are the coordinates of intersection points of the triangle? So we already found it. Now assume that the base and the height can be negative. Now what is the relationship you can find from sine 30, sine 150, sine 210, and sine 330? Well, if you look at this, sine 30 is 1/2, the y value of it, isn't it? The height of it. Sine 150, if you look at it, is also 1/2. And sine 210, which is the height, but we know that the height is going into the negative direction in this case since the triangle is upside down in the negative section for the y value. So it is negative 1/2. And then lastly, sine 330 also gives me negative 1/2. And what are your findings? Well, aren't they pretty much the same, except for the signs? And what about the cosine? So the cosine 30 degrees is square root of 3 over 2. Cosine 150 is negative square root of 3 over 2. Let's see whether this is true. Cosine 210 is then negative square root of 3 over 2. But cosine 330 is then positive square root of 3 over 2. So if you take a look at it, remember the cosine 30 was just the baseline, wasn't it? According to this calculation. And then we all see that the x value actually are the same except for the signs. So based on the angle, these are what we have. Now for the tangent, I actually want you to give this a try and I want you to find it on your own. But for the tangent 30, it is 1 over square root of 3. For tangent 150, that will be negative 1 over square root of 3. Tangent 210, that will be positive. And then tangent 330 will be a negative 1 over square root of 3. So for the tangent section, I want you to take a look at the triangles. I want you to figure this out on your own, okay? Now, one thing that you have to remember of is that where the negatives are happening for each ratio. So let's go to the next. Now, so here then will the absolute value, meaning regardless of signs, of each trigonometric ratio be the same if the acute angle, which is the reference angle, at the origin is the same. Yeah, same, right? Remember that sine 30 and sine 150, sine 210, sine 330, their absolute value, meaning regardless of what the negative sign, but the value itself was the same, right? So summary, I want you to actually come up with your own summary. There's no reason for me to put my own summary because that is my summary. I want you to actually put your own summary first, okay? Now, then, if you take a look at this quadrant, this actually is kind of funny to look at. The first one here is quadrant 1, and you're going to tell me why is that one quadrant 1? And well, that's because x and y's values are both positive in the quadrant 1. And then we take a counterclockwise, and you also may ask me, why is it going a counterclockwise instead of the clockwise, which is this way, right? The reason is very simple because it increases in terms of the y value. So as we go this way, y value increases. That's why the math is turning that way. But I cannot think of any other specific reasons for it. Now in the quadrant 2, your x value is negative. Quadrant 3, both x and y negative. Quadrant 4, x is positive, but the y is negative. Now, hopefully you remember this. Sine 30 and sine 150 both were positive values. Now, whereas sine 210 and then sine 330 were both negative, right? And if you look at it, and then cos 30, and then I'm going to actually, you know what, I'm going to rewrite it. So cos 30 was positive, so sine 30, and then sine 150 was also positive, and sine 210 was negative, and then sine 330 was negative, right? So this was the first quadrant, second quadrant, third quadrant, and then fourth quadrant. And then if you look at cosine, so I'm going to put cosine 30. Now cosine 30 was positive, and then cosine 150 was negative, cosine 210 was negative, and then cosine 330 was positive. If you go back to those angles, right? And then lastly, it's the tangent. So for the tangent, 30 told you that it is positive. Tangent 150 is negative. Tangent 210 was positive. Now tangent 330 is negative. Now there's a system called KEST. Okay, but before we introduce that, let's actually see. So what I'm going to do is this. If you take a look at quadrant 1, so the quadrant 1, which are just an acute angle that we know of, aren't these two all positive? So they're all positive. They're all positive. Now then, if you look at the quadrant 2, the 150 portions, which one's positive? The sine is the only thing that's positive. So sine is the positive. And if you look at the third quadrant, the blue one, then it's only tangent that is positive. So it is tangent that is positive. And lastly, if you look at the fourth quadrant, the green ones, only the cosine that is positive. So hopefully you can read the word out of it, that it is actually, we read it as KEST. So each letter represents which ratio is positive in which quadrant. Okay, so if you can remember that it is KEST, and then this means that everything or all means positive. Sine is positive, tangent is positive, and then cosine is positive. So hopefully you remember this. This is one of the rules that you have to remember. Now example 4. So example 4, and then I'm going to make another part. I want you to take a break. I'll probably just keep going, but you can kind of pause the video. Now find the ratio of each using the reference angle ratio. So here we know that sine 45 is 1/2. So when you're dealing with this type of question, just draw it first. So draw the Cartesian plane, approximate the 45 degrees. I don't want you to be like 100% accurate in terms of the drawing. And we know that that's 1/2. So it's given to us. Then it says, what is the sine 135? Well, sine 135 will be somewhere in between 90 and 180. And if you look at that, we always try to look for the RA, the reference angle. Now the reference angle here is then 45 degrees as well, right? That's because it is a little less than 180 degrees. And how much we rotated was 135 degrees. So then the difference here is then 45. Now, then if you look at 225, that's also 45 degrees for the reference angle. And then 315 also reference angle as well. And all you need is this. Do we have the same reference angles? The answer is yes. Then how do we know which one's positive or negative? Well, we only look at this Kesta system. So according to the Kesta system, the sign is positive in the first and the second quadrant. So that means my sine 135 will have the same ratio, which is 1 over square root of 2, but it's in the second quadrant, so it should be positive. Now the sine 225 also has the same reference angle, but it is sitting in the third quadrant, therefore it should be negative in the same ratio. And then same thing with the sine 135, sorry, 115. So sine 115 is in the last quadrant, and that gives me only cosine positive, not the sine positive. So sine is negative, that means. So that means it's going to be negative 1 over square root of 2. I want you to pause the video and give this a try, okay? But I'm going to just keep going. So cosine 60 degrees, same thing. Okay, so cosine 60 is somewhere here. So let's say this is 60 degrees. Then it says, what are the angles that give the same absolute value of trigonometric ratio? That means, first, what are the principal angles that give the same reference angles as 60 degrees? So how we do is very simple. Draw the lines, or the triangles if you like to, okay? And the reference angles inside of the triangles are all 60 degrees. And since we're looking for the principal angle, we just need to find how much you rotate. So the first angle will be 60, and 60 will also then give, not the 60, sorry, and then 120 degrees will give me the same reference angle. So it will give me the same absolute value of the ratio. Next one is going to be then 240 degrees. And then one after that is then 300 degrees. So these angles all give the same ratio, well, same absolute value ratio. Okay, so basically their numbers are the same, just the signs are changing. Okay, now then example 5. So example 5, you should be able to do it on your own. So find the trigonometric ratio of each angle. So for 60 degrees, using that triangle again, right? 60 degrees, 30 degrees, we know that it's 2, square root of 3, and then 1. So this gives me then sine of 60 as square root of 3 over 2. Cosine of 60 is then 1 over 2. Tangent 60 is then 1 over, sorry, square root of 3 over 1. Now then, what if it is 210? What? It is 210, not 60 or 30 or 45. So then first thing is you draw where that 210 is. So 210 is located in the third quadrant, since it is in between 180 and 270. And we know that the reference angle here is then the 30 degrees, right? Because from 180 you just rotate 30 degrees more, it becomes 210. So all you need is this, then create sine 210, cosine 210, tangent 210, since we're looking for all these. And remember that Kesta system again. Now, according to the Kesta system, only the t is positive. That means only the tangent is positive, and rest is negative. So the sine 210 becomes negative sine. Now, then the ratio is the same as the reference angle, 30 degrees. Now, cosine 210 will also be negative, and then tangent 210 will be positive since it is the t-zone, right? The rest you just need to find what each is. So I'm just gonna write the answers for you, but I want you to actually give this a try as you pause this video now, okay? Now this then becomes negative 1 over 2. This becomes negative square root of 3 over 2. This is then 1 over square root of 3. C and D, they are pretty much the same. So same way, 315 degrees is in the fourth quadrant. and I know that the reference angle, the angle between your terminal arm and the x-axis, is 45 degrees. So we then create sine 315, cosine 315, tangent 315. Whoop, whoop, whoop. And we know, according to the Kest rule, right, C is the only thing that's positive. That means it's only cosine. So sine 315 becomes negative sine the reference angle. Cosine is then positive reference angle. And then tangent is then negative tangent then reference angle. Now we know negative sine 45 is negative 1 over square root of 2, or we can say negative square root of 2 over 2. And then cosine 45 is then 1 over square root of 2, or we can say square root of 2 over 2. Negative tangent 45 means it's a negative of tangent 45, which is 1. So it is negative 1. Okay. Now try D, and then we'll probably take it up in class. Okay. And we will also take up this special case of 90, 180, and 270, 360. I actually want you to give this a try. Okay. And then the last example, which is this one, I will actually explain this to you because there are some new languages that you need to know of. So from a lighthouse, boat A is found 10 kilometers due west, and boat B is found at 30 degrees east of south from the lighthouse. So when you draw this, the lighthouse is at the center. Okay, whatever the thing is always at the center. That's the easiest possible way to do it. If the question doesn't state anything about its location. Now, then a boat is found 10 kilometers due west. So that means boat A is right here, and the distance here is 10 kilometers. And then boat B is found at 30 degrees east of south. So this is south. So east of south, that means this is 30 degrees. So I know that this is 60 degrees. Okay. Now, so that's the drawing. Then it says, find the sine, cosine, and tangent value of the angle of separation. Now, it's the angle between the two boats, and it is the angle that is less than 180. So it's not that we're looking for this. We're actually then looking for this much, right? Now, if you look at this, this is a right angle. This is 30 degrees. So the total angle of separation here is, so angle of separation here is then 90 plus 30, which is 120. So then we look at sine 120, cos 120, and lastly tangent 120. And hopefully remember this. 120 is in the second quadrant when you draw it on a separate Cartesian plane or XY plane. This is 120. So inside it should be 60. Now, according to the Kest rule, this will be sine zone. So sine is the only positive. So it will be just sine 60. Then this will be negative cosine 60 and negative tangent 60. And according to our special triangle, so you have to keep drawing the special triangle so that you get used to this. Okay. Then is square root of 3 over 2, and negative cosine 60 is negative 1 over 2, and the negative tangent 60 is negative square root of 3 over 1. So that's how you can draw, and that's how you can find the trigonometric ratio of angle of separation between two boats. So sorry the video is a little longer than I thought, but I think that we actually have to go through this. So hopefully this helps. Hopefully you understand how to do and how to calculate the angles from small angle to the large angle. Okay, all right. Bye guys.